Hello students, in this video we're gonna see vitamin D explanation. Vitamin D is one of the very important essay question in your university exams. So today in this video we're gonna explain everything about vitamin D. So vitamin D explanation will start from the synthesis and then functions, sources, RDA. Vitamin C is one of the fat soluble vitamins. We have four fat soluble vitamins. They are A, D, E, K. Remember them as a deck. Okay. So now we gonna see the vitamin D today. And in a series of future videos, we're gonna see A, E, K also. Among these four, D and A vitamins are essay questions and E, K most probably for short questions. Always remember vitamin D. Among all these, my preference is D is very essential for all medical students. Not only for medical students, for every paramedical and medical students, vitamin D is a very essential question to be studied. Now see, we're gonna start the vitamin D explanation from synthesis part. Okay, synthesis part. Mainly the synthesis of vitamin D starts from skin and ends with kidney. So the synthesis takes place in three organs in our body. The first one is skin and the second one is liver. The third one is kidney. Synthesis starts from skin and synthesis ends with kidney. Now in a overview, in a nutshell, the function of vitamin D has only one, which is calcium regulation. Calcium regulation. So in our body, calcium regulation will be mediated by vitamin D. The one and only function of vitamin D is calcium regulation only. So for the calcium regulation, we need vitamin D. So now we're gonna see how we are synthesizing vitamin D. How the vitamin D is getting synthesized in our body, we're gonna see. As I already told you, we have three organs in our body which are involving in synthesis of vitamin D. The first one is skin, second one is liver, and the third one is kidney. Now the skin starts synthesis of vitamin D. Now you can see here, this is a skin part, and here in the skin and epidermis of some other organs, 7-dehydrocholesterol will be synthesized. This 7-dehydrocholesterol is an intermediate of cholesterol biosynthesis pathway. Cholesterol biosynthesis pathway. Okay, this is a pathway in lipid metabolism. You will read in lipid metabolism. We will see in lipid metabolism. So whilst the cholesterol biosynthesis is going on, the pathway is going on, this 7-dehydrocholesterol compound will be produced in the middle of the cholesterol biosynthesis pathway. This 7-dehydrocholesterol will be converted to cholecalciferol in the skin by the action of UV light. We all studied from our childhood classes itself that we get vitamin D if we go under the sunlight, right? Vitamin D will be produced by the action of sunlight, right? So this UV light falls on 7-dehydrocholesterol, then this 7-dehydrocholesterol will be converted to cholecalciferol. Got it? So how we got cholecalciferol? By the action of this UV light. By the action of this UV light on the 7-dehydrocholesterol. Once UV light falls on 7-dehydrocholesterol, this 7-dehydrocholesterol is converted to cholecalciferol. Now the formed cholecalciferol will be transferred to the liver by the vitamin D binding protein. Vitamin D binding protein binds with cholecalciferol and transport it to liver. And in the liver, cholecalciferol is present. This cholecalciferol, where it is produced? In the skin. This cholecalciferol, by the action of 25-hydroxylase enzyme, this 25-hydroxylase enzyme has hydroxyl group with it. This hydroxyl group will be transferred to the cholecalciferol 25th carbon. Okay, 25th position of the cholecalciferol cholecalciferol. So there is a 25th carbon, and onto the 25th carbon this hydroxyl group will be attached. Then this cholecalciferol will be converted to 25 hydroxy cholecalciferol. Why 25 hydroxy cholecalciferol? This hydroxyl group is attached to the 25th position of cholecalciferol structure. That's why 25 hydroxy cholecalciferol. Now you see 25 hydroxylase enzyme is attaching one hydroxyl group to the 25th position of cholecalciferol. Then this cholecalciferol is turning into 25 hydroxy cholecalciferol. Now this formed 25 hydroxy cholecalciferol is now moving towards the kidney. Now in the kidney 25 hydroxy cholecalciferol is arrived. As soon as 25 hydroxy cholecalciferol is arrived here, this 25 hydroxy cholecalciferol is converted to 1,25 dihydroxy cholecalciferol, which means already 25 is there. To this 25 hydroxy cholecalciferol, one more hydroxyl group is added. That's hence 1,25 hydroxy cholecalciferol. Now who is giving one more hydroxyl group? This 1-hydroxylase enzyme is giving one more hydroxylase group to the 25 hydroxy cholecalciferol, and then this whole 25 hydroxy cholecalciferol is converted to 1,25 dihydroxy cholecalciferol, which is also known as calcitriol or triol. So calcitriol or 1,dihydroxy cholecalciferol, both are same, and this is a vitamin D form. Calcitriol is a active form of vitamin D. Remember, 1,25 dihydroxy cholecalciferol or calcitriol, both are same. Now up to here vitamin D is synthesized in the form of calcitriol. Vitamin D is synthesized. Vitamin D starts from skin and ends here in the kidney. The vitamin D now is synthesized. Now see the functions of vitamin D. The synthesis part is done. We're done with synthesis part. How vitamin D is synthesized we have seen. By the action of UV light, 7-dehydroxycholesterol is converted to cholecalciferol in the skin, and that will be transferred to the liver, cholecalciferol, and cholecalciferol is converted to 25 hydroxycholecalciferol by 25 hydroxylase enzyme in the liver, and that is transferred to the kidney. In the kidney, 25 hydroxycholecalciferol is converted to 1,25 dihydroxycholecalciferol or calcitriol by the enzyme 1-hydroxylase. And now vitamin D is synthesized. Now we'll see the functions of 1,25 dihydroxycholecalciferol or calcitriol. Now the produced calcitriol in the kidney will come out into the plasma. Now calcitriol is in the plasma. This calcitriol will work on three sites. The first site is intestine. The second site is on the bone. Okay, the bone. So this is the second site, and the third site is on kidney. Okay, this is the third site. So calcitriol shows its action on the kidney as well, where it is produced. Okay, where it has already produced. See, calcitriol is produced in the kidney, and the action is also again showing on a same organ. Okay, so mainly calcitriol performs its action on three organs, mainly, I mean three spots. They are intestine, kidney, and bone. So calcitriol acts on these three places and regulates the calcium level in our blood or plasma. So the normal calcium level in the plasma is 9 to 11 mg per dl. Okay, so we have to maintain this normal level of calcium in the blood to maintain the perfect heartbeat and also muscle contraction. These two are major functions by the calcium. What happens if the calcium level goes more than 11? What happens if the calcium level is elevated? That is hypercalcemia, which is dangerous. Hypercalcemia. What happens if the calcium is below 6 or 9, which is hypocalcemia? Which this creates a problem. So we have to maintain within the normal ranges, that is 9 to 11 mg per dl. So this level, if you want to maintain this normal level of calcium in the blood, you need vitamin D. Vitamin D works on intestine, kidney, bone, and maintains the normal level of 9 to 11 mg of calcium in the blood. Now we're gonna see how the vitamin D is maintaining the normal levels of calcium in the plasma, which is 9 to 11 mg per dl, healthy level or normal level you can say. Now see, calcitriol is just came out from a kidney and now it is acting on an intestinal cell. Okay, this is intestinal cell. Here you can see breast border, okay, villi or something. So this calcitriol enters into the intestine once it is produced. Once calcitriol enters, there is a receptor for calcitriol in the intestinal cell. Already this receptor is made for calcitriol before calcitriol. Once calcitriol entered, this receptor is incised and made available for the calcitriol. As soon as receptor formed for calcitriol, these both will be combined, okay, or attached. Now the combined form is calcitriol receptor complex. Both are attached. This is a calcitriol and this is a receptor. Calcitriol receptor complex is formed. The whole complex goes inside the nucleus, and attaches on the DNA of the particular cell. Okay, this is a DNA, you know, right? This is a DNA. So now the whole complex falls on DNA of the cell. As soon as the whole complex sticks to this DNA or binds to this DNA starts expressing and forms mRNA. This mRNA will be involved in translation. Translation means conversion of mRNA to protein. Now the protein is synthesized by the action of this whole complex. By the action of calcitriol receptor complex, you got finally a protein. This protein name is calcium binding protein. What is it? Calcium binding protein, or we can also call it as calbindin. Calbindin. Now we will see the function of this calcium binding protein. So this calcium binding protein function is, see, this calcium absorption is there, no? This calcium we have got from diet by having milk or milk products. So milk products are a good sources of calcium, right? So this calcium is dietary calcium. We got it from diet. So this is now in the intestinal level, this calcium. But the absorption has to take place. Otherwise calcium will not get absorbed and it will be eliminated from our body. Calcium needs to absorb from a intestinal cell. So through this way calcium has to absorb. But calcium alone cannot absorb from the intestinal cell to the blood, okay, or to the plasma. Calcium absorption requires calbindin protein. This calbindin protein, what it does, this calcium binding protein attaches with calcium or grabs this dietary calcium, whatever you took in a diet in the form of milk or something, any other calcium source of food. This calcium binding protein grabs this calcium and takes this calcium into the plasma. Okay, now the whole calcium whatever you are having in a diet is now in the plasma by the action of calcium binding protein, or else you can call it as calbindin. Okay, calbindin is synthesized by the action of calcitriol. Got it? Vitamin D or calcitriol. Now whatever calcium you had in a diet is now entire whole calcium is now in the plasma. So as soon as calcium is getting absorbed into the plasma, calcium level will be increased. Okay, calcium is getting absorbed and calcium level is increasing in the plasma. What I told you, the normal level is 9 to 11 mg per dl, but here by the absorption of calcium the level is getting increased more than 11 mg, so which is called hypercalcemia. So again this hypercalcemia is very fatal, so which is why this calcitriol, again what it does, whatever calcium is getting absorbed by the diet with the help of this calcium binding protein, now this calcium is going to be stored inside the bone by the action of calcitriol. What this calcitriol does, this calcitriol takes up this plasma calcium and stores that plasma calcium which is getting from diet into the bone in the osteoblast. So this calcium is stored inside the bone. So by storing the calcium in the bone, mineralizes the bone and develops the bone. Okay, calcium reservoir is a bone. So bone is a reservoir of calcium. It stores the calcium. Now, what this calcitriol is performing here? This calcitriol is increasing the plasma calcium by absorption of calcium with the help of calcium binding protein, and also the same calcium which is absorbed from a diet is going inside the bone and getting stored inside by the action of again calcitriol. Now after some time the calcium is getting stored in the bone. Okay, the calcium is getting stored in the bone, and again the plasma levels of calcium is getting low, very low, because everything is going inside the bone and the level is going down. Sometimes what happens in calcium deficiency, the plasma calcium level is very low, which means below 6 or 5 mg per dl. Normal is 9 to 11. If the calcium level is 5 to 6, what happens? Immediately whatever calcium you stored in the bone, whenever you have excess, that will come out from a bone by the action of again calcitriol. This calcitriol not only helping in storage of calcium in the bone, whenever you are deficient of calcium, then this calcitriol again along with PTH, parathyroid hormone, here see PTH, along with parathyroid hormone, this calcitriol combines with parathyroid hormone, and whatever calcium is stored whenever excess will come out now from the bone. This is called reabsorption of bone. Reabsorption of bone. So bone reabsorption means calcium will be mobilized from a bone to outside into the plasma, so that plasma calcium will be again increases up to 9 to 11 mg per dl. So whenever calcium is excess, the calcium will be stored in the bone. Whenever the calcium is less, the calcium which was already stored in the bone will come out and raises up the blood calcium level. Now we have already seen the function of calcitriol on the intestine and also function of calcitriol on the bone. Function of calcitriol in the intestine is just absorption of dietary calcium. Function of calcitriol on bone is two. One is bone mineralization or bone development, and another function is demineralization of bone by taking out the stored calcium into the plasma. So these two functions on the bone and the intestine is one function. Now the third organ is kidney. So as I already told you initially while I was explaining, vitamin D acts on three spots. First is intestine, I already explained, and bone also we have already, I already explained here, and now kidney is left. So what is the function of calcitriol on kidney? We're gonna see now. Okay, so what happens? Excess of calcium sometimes what happens will be excreted by the kidney. Whatever is not required to our body, it will be excreted by the kidney. This calcitriol, whenever you have low levels of calcium, this calcitriol acts on the kidney and stops excretion of calcium and reabsorbs the excreted calcium into the blood. Okay, calcium, whatever calcium is excreting by the kidney will be reabsorbed by the kidney again back to the kidney and enters into the blood. So it is recollecting the calcium from excreting and keeping them into the blood. Okay, calcium now in the blood, so this calcium again increases the plasma calcium level up to 11 mg per dl. Got it? So this is the function of calcitriol on three organs. The first organ is intestine, and the second organ is bone, and the third one is kidney. So this is how the calcitriol works, or vitamin D function. Yeah, one more concept I have to explain, that is regulation of synthesis of vitamin D. See how this regulation of calcitriol is mediated. See here, whenever you have low calcium levels in the plasma, immediately there is a gland called parathyroid gland, which is right behind the thyroid gland. Okay, so this parathyroid gland, whenever there is a low calcium levels in the blood, immediately this parathyroid gland synthesizes a hormone called parathyroid hormone. See here, this is a parathyroid hormone. This parathyroid hormone activates the enzyme 1-hydroxylase. If this 1-hydroxylase is activated, immediately 2,5-hydroxycholecalciferol is converted to 1-dihydroxycholecalciferol or calcitriol. This calcitriol comes into the action and again elevates the plasma calcium level. Already the calcium is low. By the synthesis of calcitriol, the plasma calcium is again increased. See here, and again low phosphate levels also activates the 1-hydroxylase. In turn, 1-hydroxylase is activated and it leads to synthesis of calcitriol again, and again plasma calcium will be elevated. Calcitriol will be produced and this calcitriol will act on intestine. Dietary calcium will be absorbed and bone also demineralizes. Everything happens and again finally what happens? Gradually calcium level will be increased. So that's how this PTH and low phosphate will influence the synthesis of vitamin D or calcitriol. And one more thing, see, we need only a particular amount of specific amount of vitamin D per day. We do not require any vitamin content more than normal. For example, if you have excess of calcitriol or vitamin D synthesis, what happens? This excess of calcitriol synthesized in your kidney will, this calcitriol itself will go back and inhibits the 1-hydroxylase enzyme, so that this 2,5-hydroxycholecalciferol or 25-hydroxycholecalciferol will not get converted to calcitriol. This type of inhibition is called feedback inhibition, which means the same end product in the pathway will inhibit the one of the enzyme in the pathway, same pathway. So that is called feedback inhibition. The excess levels of calcitriol will go back and inhibit the one of the enzyme in that pathway or key enzyme in that pathway is called feedback inhibition. So calcitriol inhibits it and stops the synthesis. Whenever calcitriol is very low or calcium is low, again synthesis starts up. So this is how the regulation takes place. Now we will move on to sources and RDA of vitamin D. So students mostly face difficulty in remembering the RDA of vitamins. So how to remember vitamin D RDA? We have so many RDAs like B complex vitamin RDAs and fat soluble vitamin RDAs. To remember the vitamin D RDA, you guys have a simple trick, which is A, B, C, D. Now what we learnt? Vitamin D. Vitamin D is a fourth alphabet, right? So now the RDA of vitamin D is 4 and 00. 400 international units of vitamin D is required per day. So this is a RDA of vitamin D. Remember like this, vitamin D is a fourth letter in alphabets and 00s, international units. The units is IU, international units. Don't write mg per dl. Okay, and now sources. Mostly vitamin D has no source. You have UV light or sunlight. If you go under the sunlight, like you will get a sunlight around 9 to 11. So in between this time, morning, early morning 9 to 11, you will get a sunlight. No, so this sunlight is enough to get vitamin D. If you go and expose your skin to this sunlight, which you will get the time between 9 to 11, that is enough. But if you cannot, for example, the areas, the snow areas or mountain, like you can, if you go to Himalayas somewhere where you cannot get sunlight, at that time what happens? You will not get enough sunlight to synthesize vitamin D. So now what you have to do is, you need to take some foods like fish liver oils and natural foods without fortifying, natural foods, and egg yolk, and all these are good sources of vitamin D. But naturally sunlight is enough for that. Okay, yeah, this is what all about vitamin D.